Hi everyone, I'm Erin Pollard and I am the project officer for ERIC and the Works Clearinghouse, which is part of the Institute of Education Sciences, the independent research arm of the U.S. Department of Education. Today I am going to be talking about the foundations of evaluation. This is a recording of a presentation done at the annual directors meeting of the Office of Migrant Education, and we are recording it to share with those who are not able to attend live. Okay, so the big picture of today, what are we trying to get out of it? We want our awardees, as well as everyone, to document and share your evaluations. We want to learn from each other. We want to make a community of practice where we are constantly sharing what we know and using the work of others to create a collective understanding of how best to serve these students. So if you are a current grantee, you need to follow your evaluation plan. You need to do what we funded you to do. But as I'm talking today, as you think through your future applications and your future requests for funding, think about how to add rigor, think about how to do better evaluations and how to share that to really kind of ultimately improve student success. Okay, so the big picture of what we're going to do today. I'm going to start by talking about what program evaluations are and what I mean by evidence. What is the statutory definition? And then we're going to talk about how to pick a good research design and what to watch out for. Where are we going to hit bumps in the road? Then we're going to talk about how do you actually do this, like when you don't have resources and materials, and then how would I ask you to share your findings? As a reminder, I am a project officer, but I am not your project officer. So if I say anything here that differs from what you hear from your project officer, you need to reach out to them. You can reach out to me. My contact information will be available at the end. But you need to make sure that you are doing what you were told to do by the terms of your award. Okay. So in general, when I think of a program evaluation, I think of a written document that describes the program. How was it implemented? What inputs were needed? So what were the costs? What were the resources? What was the time, professional development needed to implement the program and to implement it that you did? Who participated in the program? And what did the program performance measures tell you? Do you have indicators to think you were successful or not? What were you seeing? And then you have what we're going to talk about today is the program likely the reason for student successes? What is your evaluation or statistical argument that's saying this program was effective? But as we look at the top things, the ones not bolded, it is that contextual data that is often the most important part of the evaluation for me. Documenting the program is essential. You need to tell people, what did you do? What did you find? How did it work? So that way they can know, does this make sense to implement in our solution? How is what you did similar or different to what I want to do? So as you start thinking about program evaluation, I want you to think about, what is your program? Who do you serve? How do you serve them? What are you aiming to do? And how do you know you're going to be successful? Think about kind of your elevator pitch. If someone asks you, your dean, your VP, your president asks, what do you do? What is that 2 to 3 minute spiel? And then what you're going to do is you're going to take that spiel and you're going to apply it to a logic model. And the way a logic model works is these are our resources. This is what the materials we need to implement the project. These are what we are going to do. That yellow box is your activities, your strategies, and your interventions. These are your project components, your pieces. The outputs are kind of, what do you get out? What are you expecting to get out? And then your impact is, how will you know your program is successful? And this is from a toolkit that walks you through exactly how to create a logic model. The link is embedded here, and my slides I am going to be sharing. Okay, so let's take a concrete example. What is my program? I want to set up tutoring activities for students identified at risk for dropping out. Who am I serving? I'm serving students who are at risk of dropping out due to being first generation low income and from lower performing high schools. So these are students that have been identified as likely to drop out of college. And we're gonna say it's a community college for this example. How do I serve them? I'm gonna serve them through one-on-one tutoring, study sessions, and counseling. That is my program. And what am I aiming to do? My goal is to keep students in school, college, so they graduate. And how I know if I'm successful? Well, students have the grades and credits to stay in academic good standing. They graduate. And so when we share this, look at this on a national logic model, my resources are I'm going to need tutors, project director, and a dedicated office space to do our work. My activities are going to be that one-on-one tutoring, the study groups, and counseling. My outputs, what we're doing is 16 weekly tutoring sessions per semester and 15 study sessions. We're going to say we're not going to do study sessions during finals week, probably the week you need it the most, but and then for impacts on relevant outcomes, we're going to look at student GPA and credits accumulated, because both of those are important factors to a student staying in, because they need their GPA to qualify for financial aid, as well as to stay in academic good standing. And then what we're going to do is when we have a logic model, this is everything, but we're going to look at it piece by piece when we're creating an evaluation, because you don't need to evaluate everything all at once. You can just take specific components and a specific strand of your logic model. So in this case, we're going to look at the tutoring program. So we're going to say our resources are tutors. Our activity is a one-on-one tutoring program. We are going to look at the impact of those 16 weekly tutoring sessions, and we're going to look at that impact on student GPA. And the evidence we're looking for is, did attending a tutoring program increase students' GPA? So that is my research question. Now, all research questions you want to think through to make sure that they are what you want. So when you're creating your big evaluation research question, I want you to kind of think through how to be as specific and concrete as possible. So what I often see is someone asks a question of, is the tutoring program effective? Well, what tutoring program? How do you define effectiveness? I don't know what you mean. And you don't want to leave anything open to interpretation. You want something to be specific and concrete, so people know exactly what you are saying. So a better research question is, do students who participate in Erin's tutoring program have higher GPAs than students who do not? So again, you can see that we answer kind of the 5 W's. So who, the students who are participating in Erin's tutoring program, what, my tutoring program, where, tutoring, and what are we looking at? The GPA. All right, and so our theory of action here is all clear. It is one concrete sentence framed as a question. So what do we mean by evidence? So a basic evaluation asks, did students who received the program do better than those who did not? And that is what you are asking for in evaluation. Now, oftentimes I see that people are talking about pre-post studies without a comparison group. And so what they look at changes in student outcomes from the beginning of the intervention to the end. And this is a murky area that we, the Works Clearinghouse, would not consider this promising evidence. But as we mentioned earlier, we are not your program officer. You should talk to your program officer about this. And the reason for this is that we can't tell why that happened. There's no way to control what other factors happen. We're going to talk more about this later. But my message to you that we're going to say at the beginning, and this is as we think about this going forward, is that it is better to have an imperfect study with a comparison group than a pre-post design. And we'll get into why later on. Okay. But, so what about this whole thing on comparison groups? What do you mean? So comparison groups allow you to compare 2 different groups of students, because sometimes differences are what you think. So let's look at this program. And this is our tutoring program, effective GPA over time. I have 4 years of data. I see that the tutoring program, the students are showing gains. Our tutoring program is getting better. And that could be, what we could see is this, that our tutoring program is producing higher GPAs. But in general, the GPAs of all the students are going up. So there is no real difference. Our tutoring program isn't causing a difference. Or it could be that our tutoring program is, again, assuming that these control groups are statistically the same. These students should be the same as students who are in the program. The students who are not participating in the tutoring program are doing better than those doing the tutoring. We call this bad news, right? Because you want your program to be successful. And if you find that your students are doing statistically significant worse than not doing anything, that is really important information to have so you know how to improve your work going forward. While it's disappointing, and it's definitely something, it's disappointing you want to share, and then you want to share how you're going to fix this. But what you also could find is that the results are exactly what you expect. And by sharing this information, you can help justify your future funding and tell the world this program works so we all can work to improve student success. Okay. So now we are on to what do we mean by evidence, right? Because a whole bunch of, to understand evidence, you have to, and what we're talking about, you have to understand the difference between studies with a control group versus not. And when we get into the department's evidence definitions, the department has 4 levels of evidence: strong, moderate, promising, and demonstrates a rationale. We are only going to talk about the first 3 here. And when we think about evidence, it's important to know things that you can control and things you cannot control. So you should not control whether or not there's a statistically significant positive effect on an outcome, right? Because you're not fishing for findings. You're trying to give a fair evaluation, because it does no one any good for you to play around and hack the data to show that your program is effective when it really was a neutral finding. We want to know, so we know how to improve. So you want to give great information. So what you have control over is the study design. You don't have control over the outcome. We may find things that don't show a positive effect. So that is not something that you as an evaluator should be controlling. No overriding negative effects from other studies. Again, you can't control what other people do. So this is not something that these 2 star areas are not where you need to be focusing on. The size of the sample is something that you can have control over, as well as multiple locations. And we'll get into that in a minute. But what you also don't have control over is how people are using your evidence. So if I am sitting at a rural Appalachian community college in upstate New York, and you are sitting at Texan community college that is in a major city, our population and setting are vastly different. So you don't need to control the work of others. What you do need to control are this first bit and the size of the sample. So let's talk about what the difference of these evidence tiers mean. Studies that are strong evidence are well-designed and well-implemented experimental studies. And they have 350 students across multiple sites. That means multiple campuses in a higher ed setting. That's where this is going to be a burden for all of you. So if you fail one of these 3 criteria, you are eligible for promising evidence. So we'll get more to that later. Moderate evidence is a well-designed and well-implemented quasi-experimental study with over 350 students from multiple sites. So promising evidence is either a well-designed and well-implemented correlational design with statistical controls for selection bias, or it is a study that was an experimental study or a quasi-experimental study where something went wrong. The something that went wrong could be that it was at one campus and everything else is perfect, but it was only at one campus. Or it could be that it's for a smaller office that has 50 students. And so it's because it's less than 350, even though it might be otherwise eligible for tier 1 evidence, it's going to be in this promising boat. So as you are considering generating potentially promising evidence, you have 3 different designs to think of: experimental, quasi-experimental, and correlational. And my goal is to urge us into the strongest design that you think is practical. Okay. So with that, I'm going to give you an overview of the different types of research designs, so that way you understand what you can find out from these information, from these studies, what you can get. So experimental research designs can tell you that attending our tutoring program causes a 0.5% increase in GPA. So the types of these would be randomized control trials, regression discontinuity designs, and single case designs. These are the models that the Works Clearinghouse recognizes, my program office. So a way randomized control trial works is that you have two groups of participants, they don't have to be equal numbers, assigned at random. So one group gets the program or the intervention, the other group gets a control group. So that could be something else, it could be nothing. They just don't get that program. And statistically, this is the purest type of assessment, but practically it is near impossible to do, especially for programs that already exist. And so how it works is literally you could be picking names out of the hat. You could generate it in Excel. It is really just how some of you go in this group, some of you go in that group. Now, I mentioned this now because I want to be planting seeds in your head for when we get to control group. It doesn't always have to be all or nothing, because a lot of concerns with the randomized control trial are that there's ethical concerns. You have all these students eligible for a program and you're only giving the program to half of them, and you have time and money, which is a consideration. If you don't have time or money, that makes a very easy control group. But it could be that you do a little bit of randomization. So if you remember our program, we have three parts. We have tutoring, we have study session, and counseling. So let's say that we pick 4 students, or a third of our sample, to get tutoring. And a third of our sample goes to counseling. And then a third of our sample gets study sessions. And so you can compare those 3. Which of these is more effective? Do students who attend tutoring have higher GPAs than students who attend counseling, right? Or attend counseling and you use that kind of comparison. Another way is that you can do the additive model. So in case one group gets tutoring, one group gets tutoring plus study sessions, and one tutoring gets students plus study session plus counseling. And you can see the additive effects of those programs. Okay, so a randomized control trial or an RCT, that is the most common type of evaluation that gets strong evidence. There's 2 others. The first is a regression discontinuity design. And that is when there is some kind of arbitrary cutoff where some students get the program and some do not. And so the example I'm going to give is to be eligible for this remediation program, you need to get an SAT verbal score that is below 350. All right. And so I know that the difference between a 430 and a 450 and a 470 is like 1 or 2 questions. It could be a bad day. It's not like the difference between a 750 and a 450, right? That's a vastly different skill set and vastly different education level. These are all students who are, bad day, rough question kind of example. So if you were to put the cutoff at 450, and then you were going to look at divide your sample into those who had 430 to 450, and those who had between 450 and 470. All right, then you erase everyone else out, so you just have those 2 groups. You are going to take those with 430 and 450. You're going to get, they're now the yellowish light green dots. They're going to get the tutoring program. And then you're going to look at the actual yellow dots as between 450 and 470, and they're going to be the ones that do not get that. They're our control. So when you look at their relationship, the students who were in that 450 to 470, who did not get the tutoring program, their relationship between GPA and credits earned, we plot it out on this chart. And you can see that generally, as your GPA goes up, your credits go up, right? That makes sense. But then when you add in those students who receive the tutoring program, you can see that their GPA is higher and they've earned more credits on this. And when you use statistical software to draw lines, see that relationship, the treatment effect is kind of, you draw a line between those who get those who receive the treatment and those who do not. What does that affect? What does that impact to tutoring? And in this case, let's say it's 1 GPA point. So this is a regression discontinuity design. It is a really cool method. It is very hard to do well. And I encourage you, I may expose it to you because you may hear about it. It's not my favorite. For people who are not, it's there's a lot of ways that you can go wrong. So that's one of my reasons why I always caution people. The last kind of research design I'm going to go over briefly because it's not one that I can think of any practical example of why you all would use it, but I want you to be familiar with it. Only because it is a totally different way of thinking about it. So when you have a low incidence population, like students with severe special needs, we have something that's called a single case design, where you may only have a sample of one student. So if this one student we measure her baseline of her behavior. Let's say her behavior on a given day. And then we do this new program with her and we check to see what is her behavior that next week, every day. And we take it away and does her behavior points go down? Does it go up? And then we give it back. And what we're trying to see is what is that treatment? How much of it can be explained by other things? Again, this is a method that is practically not hard to do, but does not work in most higher ed contexts very well. Okay, so that's all experimental. Those are the ones that are eligible for the strong research. Or if you only have one campus, less than 350 students, or something goes wrong, which it can, will become promising. So now let's talk about those that are eligible for moderate as the highest level. And these are quasi-experimental research designs. So they can tell you that attending our tutoring program likely causes an increase of 0.5 GPA points. So experimental tells you it causes an increase, and GPA or quasi-experimental tells you it likely causes. That's the difference. There's a little bit of doubt. And here you have two groups of participants that are assigned by some non-random factor. One group gets an intervention program and one group does not. And so ways to assign students. You can do it based off resident hall. You can do it based off of campus. You can do it based off of who wants to volunteer to participate. You can do it based off of proximity. It could be waitlist, although that you could, depending on how waitlist is done, it could be experimental. There's lots of reasons, all right? And you need to have some kind of statistical controls to account for the fact that the two groups are not going to be equal. Okay, so how this works is, let's say it's resident halls. Two of the resident halls get the program, students in two resident halls, and the other two resident halls do not get the program. That can be an example of a quasi-experimental design. The students are not randomly assigned to resident halls, because that would be a disaster for your Res Life team. But they should be fairly similar, unless they're not, which we'll get into later. Okay, and lastly is correlational designs. And this is eligible for promising evidence, but the clearinghouse does not have standards for correlational design. And so what correlational design can tell you is that participating in our tutoring program is associated with a 0.5 GPA increase. So it tells you about relationships. It does not tell you about causality, and you can't make a causal claim because you don't know why. You don't know if the program caused it or if it was something else because you have nothing to compare it to. But what you do is you look at statistical methods to look at the effect of a program and without a comparison group. And so this is wonderful for quick understandings of a relationship. Is there a relationship between credits earned and hours of tutoring? Is there a relationship between GPA and credits earned? What is that relationship, and can you explain it away by other factors? You can't say that this is causal, but you can say, well, there's a relationship here. Okay, so now we're going to pause for questions. All right, what we're going to do is we're going to go on a brain break. For 10 minutes, I want you to go grab water, grab coffee, take a bathroom break if needed. And then I want you to come back and look at your evaluation plan and ask yourself, what type of evaluation did you propose? When we come back from our brain break in 10 minutes, we are going to discuss your evaluation plans. All right, welcome back. So now we're going to talk about where things can go wrong. And what else to think about. So we're going to go back to that question of why do you need a comparison group? And I'm you guys notice this is a theme that comes up because this is a part of the evaluation process we think will be the most challenging for you all. So we really want to think through how can we make this work? And how can we help you think through how to do the best possible evaluation so you know whether or not your program is effective and how you can improve your work. So, let's say students who participated in the second semester tutoring program had GPAs that were 0.5 points higher than their first semester. Well, that's interesting, but were the classes easier the second semester? Did students who were not ready for college already fail out? I mean, that was my undergrad experience. Did students who were struggling switch majors? Did the new grading policy cause higher GPAs? Did everyone's GPA grow up, not just those in the tutoring program? Those are the questions and concerns that will come up if you do either pre-post test or just a purely correlation design. And you won't be able to answer those. So when you have a comparison group, you can start to kind of whittle down some of those questions. So some good ways to create a comparison group were students who were eligible for the program but didn't apply, or so for whatever reason, they might not have known about it, they might not have chosen to apply. You don't know why they're different. It's quasi-experimental, so there could be reasons why they chose not to apply that are related to your intended impact, but they still are really good comparison group. There's also probably the best students who applied for the program, but there just wasn't space, so you did a lottery. That would actually be randomization, as long as it wasn't compromised. Even if it was compromised, it could be a quasi-experimental study, which would be great. Then you can look at students who are demographically similar to those in the program, that while they might not have been eligible, they might be from very similar backgrounds. And lastly, what you can do is you can look at students who participate in a similar program for similar demographics. So when I think of programs that we have that in my community, we have programs that are seeking to help individuals receive their GED. And we have programs for migrants and for different newcomers, but you may have, I would be hesitant to compare the program for our newcomer Afghan refugees or newcomer Ukrainian refugees with those for migrants, because I think that those populations are going to be very different and that isn't that best experience. They're still going to have like this huge culture shock and lots of things going on. But realistically, it is probably a very different types of culture shock. So I would want to look at programs that serve pretty similar populations. And can use that as a comparison group. So why is this better? When we think about this, these two groups, they would have taken the same classes. So we're going to use, for an example, for a freshman program, we're going to use those who applied, but there wasn't space. So these students would have taken the same classes, the same prior achievement. They would have had the same ability to drop classes and switch majors. They were impacted by the same changes to policy, and their GPAs should have been influenced by the same factors. So when you have a comparison group, all of those what ifs are no longer factors. You know that it's just likely your program caused this. And that's what having a comparison group really can help. So let's say you don't have a really good option available. It's real life. So a different option is, and when I say less great, so these are less great than having no comparison, but still much better than it, or less great than the comparisons that we had previously, but still way better than no comparison. So you can students at another campus. You can use students from a previous cohort. Now, again, let's say you're looking at there's going to be problems there, right? That if you look at students who in that year before, there could be weird stuff about that year. I always think about it as, let's say you're comparing students in the 2021-2022 year to those who in the 2019-2020 year. That was a weird time. There's weird things that would have happened to their GPA. It was a weird time. So there's going to be external factors outside of people's control, but it is still better than having no control group. Or you can use students who are not demographically similar. And so what that might mean is that you may not be able to compare all of your students, but you might be able to do some statistical controls to try and compare how are they doing to other parts of the population. And so with this, let's say we're going to look at students who are at a different branch campus. So I am sitting here at Nova Alexandria, and I'm going to compare this to Nova Fairfax. But sorry, Nova is Northern Virginia Community College. All right. So generally, the students would have taken the same classes by different professors. They would have had the same prior achievement. They would have had the same ability to drop classes and switch majors because they're from that same program, same overall system. But there might be different policies that impact each group. And their GPA could be influenced by different factors. So it's not perfect, but it's still like better than the questions and the doubts that we had at the beginning. So what if there's no obvious control group? Well, okay, that happens, right? I've been an evaluator when this has happened. So one thing is you don't need to evaluate all of your students. Is there some small group that might be comparable to others? So when we look at a program, it may be that the bulk of your students, you don't have a comparison group, but there is a program for let's say migrant women that serves a very similar population that you can use to compare to your students. Another option is that you don't need to do treatment versus nothing comparison. Can you give half of your students one program and half a different program? Like the example we saw at the beginning, or the program plus something extra? Are there ways that you can take your program and just segment it out so you're making a comparison group within your program? And then lastly, are there similar programs in the community? And this is not a higher ed example, but when I was doing this at working on evaluation where I could not think of a good control group, we realized that the state-funded preschool and Head Start both served low-income 4-year-olds. And while the income eligibility was slightly different, it wasn't like that different. And both programs existed in the same county, the same town, and often the same school building. So it worked, it fit. Again, it may not have been perfect, but it was still really good. Okay, so now that we've talked about control group, I want to go through what are the other 3 big things that you need to be thinking about. First is baseline equivalence. Are the groups similar? The second is power. Do you have a big enough sample to see the impact? And the third is confounding variables. What else can be causing this impact? So with baseline equivalence, sometimes groups may differ on characteristics that are likely related to your outcome of interest. So let's say we're trying to increase the GPA through tutoring program. Same example we've been working on. What if the honor students preferred same dorm? So when you look at this, there's honor students in all of them. But they greatly prefer these 2 dorms. That may not be the best comparison group, right? Because you would expect honor students to have a higher GPA. But you also could probably, what I would say is that it doesn't say don't use this. It means that you have to add a statistical control to your model, which we'll get to at the end about baseline equivalence, about participating in the honors program. Okay, and then what if one dorm had both freshmen and sophomores? Okay, so you know that in order to be a sophomore, you would have had to not fail out your freshman year. That means that you would have had to gain enough credits at a high enough GPA to be a sophomore. Therefore, that may not be the best comparison group, right? Because if this is for a freshman tutoring program, you know that these students are going to be different. Okay. And so how I'd handle that one is by dropping the sophomores out of the sample. So that there's ways that you can think about it, right? You still could use this, but what you either have to do is narrow your population of interest to just freshmen, or put a control in your model to say for sophomore. So that way you account for them. Okay. Other things to worry about is power, which is the likelihood of detecting effect where there actually is one. And it's comprised of mainly three things: sample size, effect size, or how big of an impact you're expecting, and significance level. So how big of a statistically significant effect that you expect. And there's calculators online to do a power analysis to determine the small sample size likely needed to find a positive effect if the program actually works. So I recommend thinking through one of those, and they're really easy and intuitive. And so why you do this? Well, there's two ways that power can be a concern. Your program is effective, but the sample size is too small to determine effect. And so this means that you wasted resources doing the evaluation. With the caveat, we are telling you to do this, you aren't funding it yourself. So yeah, it may be, this is less of a concern for you. And you still don't know if the program works or not because it wasn't a big enough sample to determine an effect. So what I would say with this is ideally you want a big sample, but I would take a comparison group and a more rigorous design, even if it is undersized any day, because you're adding to the evidence base and people can learn from that. And then next time they could replicate your study with a bigger sample and you might see that effect. So while worried about power, I have to mention it. It is not my, I would rather you not have a positive, statistically positive, significantly significant positive effect. Well, maybe disappointing to you, but know that it's likely because of power. The other thing that could happen, rarely happens in this kind of program, is that your sample size is so large that you find a statistically significant difference, but that difference is so small to have any practical meaning. Think about like 0.01 GPA points. So if you had to go out and get consent and get all these people to participate in the evaluation, you have found your positive effect. Good job. But you've spent so much money doing it that that's not really a good use of your resources or our resources. So this is different if you're using administrative data and you're not having to go out and collect all of this. But if you have to go out and individually get consent from every single student, you don't want to get any larger of a sample than you actually need. Okay. The last thing we're going to discuss in this section is confounds. So compounding variables are when there is an observed characteristic that could be responsible for the change other than the intervention. So let's say that the yellow dots are non-athletes. Okay, all the athletes are where you're doing the tutoring program. So why am I concerned? Well, I know the athletes in my, where I went to college, had to go, it was D3. But let's say it's D1, right? You have money on the line. You need to keep your scholarship. You need to keep eligibility to play. That is a factor that impacts GPA. But when you think about D3 or blanking on the name of the conference for two-year schools, JCAAs, I think, you still have mandatory study halls. You have pressure from your coach. You have pressure from your teammates. And you have tutoring if your GPA starts to fall. The coaches are in your business to keep your grades up. So here, it is really concerning to me that the blue dots are all getting double dipped tutoring. So I don't know if the program is athletics or if it's my tutoring program. So that would be something I'd be concerned about. And because they're all overlap, I can't tease it out. If you had some athletes in the other dorms, then you could tease out that effect statistically. Okay, so when to add in statistical controls or covariates? So that's when there are observable, measurable traits that could cause effect. So things could be like prior achievement, SAT score, high school GPA, although that's not always my favorite. It could be demographic things like race, ethnicity. It could be income or measure of need, eligibility for Pell, and it could be language status, right? So if I And we can see this as either language spoken at home, primary language, or like a TOEFL score. But I want you to think about your models here, about how much of the fact can be explained by other factors. And I always say to include covariates, these controls, where there's not baseline equivalence, but also think about, are they actually needed? And so an example of this is if you are working for a migrant education program, are you going to have that much diversity on native language? Are you going to have that much diversity? You may, right? Some of you do, but you also may have a situation where everyone is a native Spanish speaker. You may have a situation where race and ethnicity may not really explain that much because all of your students are, or the majority of your students are Hispanic. Now, it could be a case, right? That's not exclusively the case, but it could be a case where you are seeing not a lot of variation there. So then you don't have to include it in your model. Oftentimes, students might be eligible for Pell. You might have everyone. So if everyone's eligible for Pell, that's not going to explain any much of that relationship. So you don't need to add it to your model. Does that all make sense? Okay. So why we added covariates? So let's say this program looks effective, but is it? What if we control for SAT score? Boom, it goes away, right? That what? Because SAT score, well, totally not perfect, is a measure of prior knowledge. So what have we learned so far? All right, I like this little comic. I think it is helpful. That this is just, while we are the Institute of Education Sciences, it is more of an art than a science, and there's a lot of things that go into it. So I know your brain is probably brain soup right now. So what we're going to do is we are going to go into a brain break, and I want you to take 5 minutes to look at your evaluation plan and ask yourself, how are you going to make a comparison group? How will you determine baseline equivalence? What types of statistical controls or covariates did you propose and why? And how did you address power and sample size? Then, after 5 minutes, I'm going to announce that we're going to just take a minute for you to find 2 to 3 colleagues. I am not going to assign you because no one likes that. And I want you to discuss for about 5 minutes, what types of evaluation are you using and why? And how are you going to create a comparison group? And what types of controls are you using? And then we're going to come back together and we're going to talk about this. Okay, so now that we're back from that group activity, let's talk about how you actually do this. And the way that you basically always do statistical controls is through a form of regression, which uses this equation here, which don't worry, you are not expected to do this by hand. But if you remember way back to middle school, high school math, this might look like the equation of a line, right? If you're going to plot out a line, and this is called y equals mx plus b. And so what this works in algebra, hang with me, I promise it's important, is that if you plot a graph, y is one axis, x is the other, and so this is giving the slope of a line and where the line crosses the x-intercept, or y-intercept. So what does this mean? Okay, let's say that we are trying to improve freshman GPA through a tutoring program. Our favorite example. The basic model would be the GPA, your GPA as a function of an SAT score. And what that second thing will be that minimum GPA point. Where do you start that line? And we're using SAT score here because you need to have some kind of continuous measure to make this make sense. You don't want to do a dichotomous, a yes, no. So you want to have something that, has numbers. Okay, so let's look at this model. So what this would say is that y is your GPA as a function of your SAT score. So if B is where if you had an SAT score of 0, which we all know is not possible, that 200 is the minimum, but just hang with me here. Your GPA score was 0, where would that line, if your SAT score was 0, what would your GPA be? All right. And then the M is the slope of that line. That means that that means kind of what is that angle of the line. And so what this tells you is if you knew someone's SAT score, what would be their most likely GPA? And so what you would do is, let's say your SAT score is 400, you would find 400 on the chart, you come up here and you say that their GPA is likely, let's say 2.0. I don't know, we're making this up. Now, what you can see realistically is some people are a lot lower, some people are higher, but this is your best guess. Okay. So that's just a basic regression. Then what you can do is you can add in covariates. And one of your covariates might be did you participate in the tutoring program? So if you did, it's going to essentially create a second line, a second slope for the tutoring program. And here, what that will tell you is that the difference in slopes is the effect of the program. So this is telling you how much is that expected difference, average difference, different when accounting for students' SAT score, so their prior knowledge. Okay, so that is basically what we're doing. So when we think about our model, you want to think about the things that you can observe and have in your data, right? Because you're not going to have all the data that you want. That you would expect would impact the outcome of interest. So you can think about the things that we mentioned earlier. And so in this case, we're going to look at our data. Here are our 12 students, and whether or not they participated in the tutoring session. I have their SAT scores, their GPA. So we're gonna say that this is first semester. We have their ethnicity, and here you can see that they are all Hispanic. We have their sex or gender, and here you see it's a mix, and Pell status, and all of the students have Pell. I don't have language. I might have wanted language. I don't have it in those data. So even if it might be a really important factor, I'm either gonna have to get those data or work with what I have. All right. So the first thing I'm gonna do is I'm gonna check for baseline equivalence. Do the students who participate, those with the Y, are they similar to students who did not participate? So what I'm gonna do is I am going to check the average of those who participated with those who did not participate. And what I'm gonna see is that the GPA was higher for those who participated. But it was it was probably not statistically significant. Generally, you use less than 0.05. But it's on the border, right? The SAT verbal score is largely the same, statistically no difference. Their math score the same, no difference. The participants were a little more male than female, but statistically no difference. And everyone was Hispanic and everyone was on par. Okay, so what I know is that none of these covariates none of those controls are statistically significant, so I don't need to add any of them, but I always feel better adding things to the model, so that way, if I think that they would excite, and I think that prior knowledge has an impact on GPA. Okay, so the first thing you're gonna do, and I'm doing this in Excel, because I know that my parents are in higher ed and they didn't have access to SPSS or Stata or R or any of the tools that make this easier. And so it is completely possible to do this in Excel. We'll get into other ways to do it afterwards. All right. So first thing I'm going to do is I'm going to transform my data so the computer can read it. So that means my yes, no's need to go to 0, 1. So this is going to be yes. So instead of sex, gender, I have male. Male is 1, 0 is female. Hispanic is 1. So it's not race or ethnicity. It's anyone who's Hispanic, it's a 1. Anyone who is not Hispanic, it's a 0. Same thing for Pell status. I also put my data into different rows. So I start with my intended, what I'm trying to cause an impact on, my Y variable here, my GPA, and then my participation here. And then all my potential covariates here. And that's just because working in Excel is sometimes clunky. All right, my chart isn't working. All right, so the first thing you're going to do is you want to look at the data to see if there is a relationship. So in Excel, you are going to go to the Insert tab, and then you are going to come over here to this little chart tab, and you are going to select the bubble chart right here. And what should happen is that should be the chart that you have, and you want to make sure that it looks right. And what do I mean by looks right? You're not trying to guess the relationship or how this is going to go. But if I saw an SAT score of 1,000, that would be a problem because the maximum that you can get is 800. If I saw an SAT score of 730 and I'm sitting at a community college, I might also look at that because that would not be what I would expect. If I saw a GPA of 7.2, I would also know that that's a problem, right? Because we would expect GPA to be less than 4. And that's how it's pretty standard. Okay. So next, what you are going to do is you are going to go back to Excel because there's no real problems here. And you are going to search for data analytics, which you probably don't have, but Excel knows what I'm searching for, and it's going to go to add-ins. So you're going to do the add-ins, and then you're open it up, and you're going to select analysis toolpath. And then what you're going to do is you're going to go to the data tab, and then you're going to hit data analysis, and this little pop-up is going to pop up, and you're going to choose regression, and you're going to hit OK, and then you're going to get this box. All right, so the first thing is Y. Y is GPA, so you're going to select the GPA range, and then you're going to select the X range. And so this is all of the this is your variable of interest, so whether or not you participated, plus all the covariates that you want to increase, and all of them have to be kind of in a square rectangle. So I'm choosing SAT verbal, SAT math, and mail. All right, and then I hit OK. I should have showed the heads up it's talking. All right, and it comes out into a new tab. And you get this. You're like, I don't know what this is. All right, so this is where we're going to go through what is most important. Right, first is adjusted R-square. And that tells you how much of that relationship is explained by your model. So we've explained about 42%. That's not great, but you know what? It's what we have. I would have liked to see a number closer to 0.7, but you do what you can, right? And so what I would do if this was me is I would like to say, are there other variables that I should be entering in? Are there other data that I don't have that should be good to add? All right. Then I go back to look at our participation of interest, and it's 0.5. So that is 0.5 GPA points. That is huge. So I go and I look at that. That's our impact. All right. But is it statistically significant? Yes, it is below 0.05. That is exciting news. So this, we can say that from our undersized model, we do not have a large enough sample size. Our power analysis would say we needed a lot more kids, but we did what we had, and we still saw a statistically significant positive effect. When we controlled for prior achievement or prior knowledge with your SAT scores. So that is the basics of a regression. Now, what's another way that we can do it? You can phone a friend. I encourage you to use your resources. If you are at an institution that has a graduate school, specifically a public policy program or a statistics program or economics program or a psychology program, sociology program, you have people that have statistical software and the ability to run this regression very easily. It is well worth a few work study hours or a small stipend to have them as a consultant to do this. Let's say you are at a community college where you don't have that. This is where you can go talk to your faculty who might be in the econ or the psych department and say, hey, can you help me with this? There are plenty of trades that people will be happy to do this and that are well worth it for your time. And I think that this is oftentimes the way I would do this is I would tap into my resources. Because it is, again, for me to do this, a regression, get the data, do this, we'll probably be talking to you for half an hour and then like an hour on my laptop. It is not a huge lift. Writing up the report, writing up that section, that would be more time, that would be a bigger lift. That would probably be something I recommend outsourcing as well, but that is something that you also could do yourself, right? Okay, so now that we've done all the steps, what do we do? So let's go back to this slide, the parts of the program evaluation. You should write up, what is the program? How is it implemented? What are the costs? Who are we for instance? And then did it work? Did it work for everyone? Are the effects same for everyone? This is where you write what you did and how you found what you found and what you found. And it's important to include what you have and also talk about what you don't have. So I didn't have all the variables I would have wanted to include in my model. I would have wanted to know, were the students STEM majors? I would have wanted to know other factors, but you use what you have and you document what you can. Okay. And these are the questions that I try to answer in my report. And as I think about writing my report, it should be a document. It should be like a PDF. It can be as few as 10 pages, 7 pages. It could be as long as 300. I could say as someone who reads evaluations. You want to include all the information there so someone can do it. But you also need to be judicious, and no one wants to read a 300-page document. So most really good evaluations can be done in that 10-page, 20-page format. And it doesn't have to be, a super fancy, well-formatted document. It can be boring in Microsoft Word. Okay. If you have surveys or extra information, or you can put them into an appendix. And yeah, you just really encourage you to think, if you were receiving an evaluation from someone else, what types of information would you want in it? Okay, so now we're gonna get to, you've done the evaluation, you're all happy, proud. You are not done yet. So we're gonna go back to what I said earlier. I am a program officer. I am not your program officer. So you must talk to your program officer to make sure that they agree with what I am saying. But from my understanding, you must conduct an evaluation and you must share that evaluation with your program officer. But you should, this is not must, but it's, we're going to guilt you into being good, productive members of the research community. You should share your evaluation for colleagues. The people in this room want to learn from you. They want to learn about what worked, what did it, how can we take what you learn and apply it to our setting so we all do better. And you also should share the evaluation with the world, specifically with Eric. Why, right? This is your network and you want to share what you know with them and teach from them. We also want to share with Eric because there are people who aren't in this room who are trying to serve the same populations, and they are trying to learn from you, and they're trying to build that evidence base and try to think through new solutions, new strategies for you. When you put your work into Eric, it is preserved for perpetuity, literally for the life of the Republic, in the same way that the Constitution is. And so what does that mean, right? Because that sounds a little ominous. I'm like, oh, this is big and scary. It doesn't mean that. It means that people 10 years from now, 20 years from now can look back and say, oh, that's what that program is. Huh. I wonder, did that work? Didn't it work? Another thing that I hear hesitation is that people don't think that their work is good enough to be an Eric, like especially if it didn't find positive results, or you're not confident that your model, regression isn't your jam. And this was a big scary thing and you're sure you didn't do it right. You know what? Like, it's still really good to have that information. Yeah, it's not perfect, but most evaluations in Eric are far from perfect. And even if I might have designed it differently, right? I was in your shoes, and I can learn so much from that contextual data, from that beginning part, that I will use that, and it will really, really help make our community do better work. Okay, so submitting to Eric. In the footer, so you go to eric.ed.gov. The footer has the submit button. So that's where you go to submit. You hit begin, and it is a simple web form. It takes 5 minutes. So again, I know I've been harping on this. The one thing that is that when we think about funding decisions and people look at the funding, what has been funded doesn't work, we don't always get a chance to talk to you, but we do get to see those documents that are those archives. And so putting them in ERIC allows the clearinghouse to take them and review your evaluations, but it also is used by others who are making funding decisions. So yes, please share. That's a duplicate. All right, so to recap, share your evaluations. We want to learn from each other. Follow what is in your evaluation plans. You need to talk to your project officer before you make any changes. And going forward, as you think about improving your work, think about how to add rigor. All right, what questions do you have?